Welcome back to Tech Pulse, your go-to show where we break down the latest breakthroughs in science and technology, making them not just digestible, but actually exciting. I'm Zaper.
And I'm Puck. Think of me as your front row seat to curiosity. I'll ask the sharp questions and challenge the details so you don't have to. Quick reminder, smash that subscribe button, drop a like, and share this with a friend who geeks out about space as much as we do.
All right, today's headline is wild. Astronomers have found that the universe was warm before the first stars, not icy cold like we've all been told for decades. This discovery from the International Center of Radio Astronomy Research completely upends the cold universe theory we've been spoon-fed.
Hold on, Zaper. Let's not jump to completely upends. Sure, they didn't detect the expected cold universe radio signal, but absence of evidence isn't proof of a radically different reality. It could just mean our instruments aren't sharp enough yet. I'm not ready to toss out decades of cosmology because one team says the gas was preheated.
No, see, that's exactly why this is groundbreaking. 10 years of data from the Murchison Widefield Array, 10 years of cutting-edge filtering, subtracting background noise, stripping out contamination. If after all that they still don't see the cold signal, then yeah, cold reionization is ruled out. The early universe wasn't a freezer, it was already warming up, maybe from primitive black holes spewing out X-rays.
Or maybe, we're over-romanticizing. Every decade, we claim we've rewritten the universe's origin story. Remember when dark energy was the magic bullet? Or when we thought the cosmic microwave background had anomalies that proved multiverse theories? A lot of those flashy announcements fizzle. This could be another hype cycle.
Except this isn't hype, Puck. It's data. Hard, 10-year-long, peer-reviewed, published in the Astrophysical Journal data. The fact that the universe wasn't the icebox we thought changes how we model star and galaxy formation. That means revisiting simulations, rewriting textbooks, maybe even rethinking when and how the first light truly broke through.
Fine, but let's be real, saying rewriting textbooks is the exact kind of sensationalism that gets people rolling their eyes at science. This study didn't hand us a neat answer. It gave us another layer of messy complexity, which is great, but it's not the Big Bang 2.0. It's a clue, not a conclusion.
But that's the beauty of it, isn't it? Science isn't static. Every discovery is a shakeup. And if we downplay findings like this, we keep people stuck thinking the universe was some silent, frozen void until stars flipped the lights on. No, it was dynamic, noisy, maybe even chaotic from the very beginning.
And I'll counter, if we oversell it, we risk losing credibility the moment a new dataset contradicts it. I say celebrate the progress, but keep the champagne corked until we've seen what the Square Kilometre Array digs up. That telescope is going to make MWA look like a toy.
So, to wrap this up, evidence points to Einstein's universe still holding strong, but Hawking and now these Curtin University findings are pushing us to see the cosmos as warmer, wilder, and way less predictable than the cold dawn story we grew up with.
And for me, it's a cautious celebration. Incredible methods, exciting hints, but the big answers are still out there. The Square Kilometre Array will decide whether this is a revolution or just another puzzle piece.
That's all for today's episode of Tech Posts. If you enjoyed this clash of cosmic opinions, hit like, drop a comment, and of course, subscribe so you never miss a moment of the future.
I'm Puck.
And I'm Zaper. Thanks for tuning in. See you next time on Tech Pulse.